Hi everyone and welcome to eSchool Bell. In this video, we shall see question number 13 of the exercise 10.2 of CBSE class 12 vector algebra chapter. The question states find the direction cosines of the vector joining the points. You got the coordinates of point A 1, 2 and minus 3 and coordinates of point B, which is -1, -2 and 1, directed from A to B. So basically here, to find the direction cosine of the vector formed between A and B, you got 2 points, basically point A and point B, and you have a vector directed from A to B. So the coordinates of A is 1, 2, -3. The coordinates of B is -1, -2, -1. First, you have to find the equation of this vector AB. Equation of vector AB is given by B vector minus A vector. So B vector is -1 I cap -2 J cap plus 1 K cap, and A vector is 1 I cap plus 2 J cap and 1, correction, it's not 1, it's -3, and -3 K cap. You have to separate these two vectors. So when you separate here, it will become -2 I cap, and this one will be -4 J cap, and this was going to be minus plus 3, so plus 4 K cap. So this will be the equation of the vector. Now for this vector, we have to find the direction cosines. Okay, before we find the direction cosine, we will see how this vector looks in a 3D geometry. Okay, so let's shift to 3D geometry. Okay, in 3D geometry, I have the same question in the coordinates of the same question, point A and point B and the vector. So you can see this is point A with coordinates 1, 2 and -3, and point B with coordinates -1, -2 and 1. So now we have to find direction cosine for this particular vector from A to B. To solve this question, see, we can find the direction cosines of a vector when the vector is passing through the origin or starting from the origin. But here, the vector is not passing through the origin or starting from the origin. So, to solve such problems, there is one important property in vector algebra known as the free vector, because the vectors can be shifted. The vectors can be freely moved. Okay, if you move this particular vector onto the origin, then we will get the coordinates basis the origin, which will be the position vector for this new vector, and also we will also can find the direction cosines when we shift this vector to the origin. So let's shift this vector to the origin. So to shift the vectors, so I'll select the starting point of vector here, and this vector needs to be shifted. Now you see I shifted the vector from the origin. Now if you see both the vectors, they are parallel vectors. You can see, I can show you in all directions, there will be parallel vectors. Now if you see the coordinates of this point B, see now we can see the coordinates of this vector after shifting. So the coordinate at point A dash will be 0, 0, 0, because that's the origin, and the point at which the vector finishes will be -2, minus 2 comma minus 4 comma 4. Okay, this is the same value which you will get when you subtract b vector, the coordinates of this b vector, the coordinates of point B from the coordinates of point A. When you subtract these coordinates, you are going to get the same value, and that value is this. Okay, now we have to find direction cosines of this particular vector. So we can simply use the formula and find the direction cosines. So let's go into the calculation part. So let's see the calculation part again. uh, this will not be BA vector, this will be AB vector. For simplicity's sake, I will name this vector as R vector. R vector is equal to so and so. Now, what will be the length of this R vector? That will be the magnitude of R vector, which is root of x square plus y square plus z square. Here, the components of I, j, k will be the value of x, y, z. 2, minus 4, and minus 6. That will be root of minus 2 the whole square plus minus 4 the whole square plus 4 the whole square, that is equal to root of 4 plus 16 plus 16, that is equal to root 36. Then the value will be 6 units. This will be the length of the vector, resultant vector AB, which we named as R vector. And cosine angles, the formula is given by cos alpha is equal to L is equal to the coordinate of x coordinate divided by the length of the vector, which is R vector here, or the magnitude of R vector, and cos beta is M, that is equal to y coordinate divided by length of this vector, and cos gamma is equal to N, which is z coordinate divided by length of R vector. So that will be minus 2 by 6 comma, this will be L is equal to minus 2 by 6, M is equal to minus 4 by 6, and N is equal to plus 4 by 6. This will be equal to minus 1 by 3 comma minus 2 by 3 comma plus 2 by 3. So these are the values of L, M, and N. Since direction cosines are asked, you don't have to find the value of the angles. You don't have to find value of cos angle, cos beta, and cos gamma. So you just have to find the direction cosines, which will be minus 1 by 3 comma minus 2 by 3 comma 2 by 3. This is the answer for this question. Hope you understood this explanation. Thank you for listening. Let's see in the next video.